Yo, it's Rich Top, AI in the house. Plug in, level up. We building right now. From zero to hero, no cap, let's go. Build with AI. Yeah, we stacking the code. Prompt the power, watch the future explode. Newbies, listen up. Rich Top on the flow. Lessons from the grind, now you ready to grow. AI in the zone. Rich Top teaching, never build alone. From beginning to beast, yeah, we own the throne. Build with AI, make it your own. Yo, started simple, just a curious mind. Copy, paste prompts, yeah, I wasted some time. Trial and error, prompts crashing like bricks. But I kept pushing, learned all the tricks. Don't just ask, direct it like a boss. Act like a senior dev, no fluff, no laws. Chain your thoughts, break it step by step. Few shot examples, now you got the rep. I was intermediate, still learning the game. But every fail taught me how to elevate the name. Rich Top AI, streaming live every night. Showing y'all the path, turn the dark into light. Build with AI, yeah, we stacking the code. Prompt the power, watch the future explode. AI, yeah, we stacking the code. Now I think different mindset on lock. Parallel agents, multi-thread the clock. No more one shot, I orchestrate the crew. Lane chain flows, make the model pursue. Tools in the mix, web search, code run. Don't fear the loop, let the agents have fun. For the new ones watching, start smart, don't stress. Build a simple bot, then scale to the next. I drop gems weekly, real talk, no hype. Mistakes I made, so you skip the white. From prompt engineer to full stack creator. AI ain't the future, yo, it's now, see you later. AI, yeah, we stacking the code. Prompt the power, watch the future explode. AI, yeah, we stacking the code. Yo, pause. Feel that bass hit deep. That's the grind, that's the leap. Rich Top AI, we don't sleep. We build, we teach, we keep it elite. New blood, come through. Grab the seat. Let's construct tomorrow. Make it complete. So log in, hit play, join the live stream squad. Rich Top, dropping knowledge. Applaud if you nod. From no code news to coding with flair. AI's the tool, you the one unprepared. We building empires, pixel by pixel. Futures wide open, make it official. Shout to the fam, tuning in every week. Together we rise, no cap, that's the peak. Yeah, we stacking the code. Prompt the power, watch the future explode. Rich Top AI, build mode.
I'm such a pro at this. I've been talking away with my mic off. One of these days, I'm going to create a checklist. A checklist that works. So I'm going to back up. I'm going to back up here and I'm going to start all over explaining what we're doing. So what we got is we're going to run this process I call Forge. And it's basically a loop where we run Claude Code headless. And we bring in, I can define how many runs we're going to do, how many instances come in. So let's say we're going to do 5 runs. So that's going to bring in 5 different instances. And they're going to come in and read this seed document. And within that seed document is instructions. And it could be just that. It could be instructions, or it could be a problem that you're trying to solve. It could be a plan, which is kind of what we're going to work on tonight. Or it could be a combination, which is really what we're going to do tonight. Is it could be a problem and a plan. So we have the problem defined, and we have part, I think, of a solution. But we're going to use this Forge process, this CIRC, which stands for Single Instance Recursive Knowledge. But it's just a way for instances to come in, do a job, and then they're going to save their context in this tool that I built called Mandrill. This is the first tool that I ever built. There's no way I could build anything without this thing. It's the reason I built Mandrill was because I knew I needed something like this to be able to work with AI. And everything about this was AI first. So it's a way for me to basically manage projects, and also a way for these instances or Claudes or AMP codes or GPTs, whatever LLMs you want to run, can use this database to save context. So when we are working on a project, this is where we store everything that we do from start to finish. And that's why I can start new threads, quite often. I don't really worry about that because everything's in here, right? All my context is right here. This is my context management. So it works for me. They can semantically search because it's a vectorized database. And that has been invaluable numerous times because it's how I can maintain a project too. People always talk about, well, you can build it. Yeah, but how do you maintain it? Well, this is my answer of how you maintain it, because my complete history is in here, including any, like I said, any decisions, any major decisions, you can store those here and know why you did something. So that's the idea here. But in this particular case tonight, we're going to use Mandrill to do their job. They're going to come in and save context. They're going to save their plan, what their plan is. Then they're going to save a context on, after they read first. Well, let me back up. The first thing they're going to do is come in and read any previous context in here. That's always the first thing they do, because that gets them up to date on what we're doing. So they're going to read this seed document, which is going to point them here and also give them a description of what we're trying to do. They're going to come in here after thinking about it and save their plan. And then again, after they do some more research or context gathering, they're going to, do whatever that task is that they're going to do. Then they're going to save a post completion or a completion context. And then what they should do is then do a final handoff context, which it kind of summarizes what they did, the reasons, and this is important, the reasons why they did something. And then we also encourage, challenging of the previous instance's work. So then we're going to loop another instance that's going to be, a completely new context. Not know what the other one did other than come in and see the work and then read this context from here. And then what happens, hopefully, is they build off of each other's previous work, which essentially saves on tokens. They also compound their thinking. I've seen some, I'm not going to sit here and say they do novel things because I've not seen that, but you can get more out of them. You get them in more meta thinking this way, and you don't get those first run tokens, which is not what we want. We want those deeper tokens. So that's what the plan is. It's that kind of loop. That's a pretty basic loop, but when you give them a database and give them something to build off of and a direction, they can do some pretty cool things. So what we got to do is test this to see if it's going to run. Because like I said, I've been scrambling. So we're going to start it in this Ridge Control terminal, and this is how I start it with the circ panel. And hopefully I can, so we're going to call this forge test, and then I give it the date. Today is tax day, right? Tax day. And then our seed document is just in seeds. And the name of that is the same test. And my typing's terrible, so I'm old. And this keyboard is horrible. Got to get a new one. Blame it on the keyboard, man. And we got to get music. What is going on with that? That's better. It's mo better. All right. We got that. Now we're going to run, this is how many instances we're going to run across it. So we're going to do 5 for a test. Because all I want to see is make sure that they can connect to Mandrill. And this is the Mandrill project that they're going to. Yeah. And then we're going to just say yes, self-assigned numbers. This is the moment of truth where we get a womp womp or we get a yes. And we get into womp womp. Yeah, that was bad, man. So we're still getting that same error. It's not passing that health check, and I thought we fixed it. And let me, no, because I restarted. I'm going to have them check it. Man, something is going on with my tiling windows tonight. I don't know what I'm doing. I'm doing something wrong. There we go. Let's bring this guy bigger. I have time I've restarted the servers. So we're just telling them we restarted everything to get our connections. We should be go here, and yeah, we were connected down here. Everything was running fine. And this is our server for Forge. This is how we're going to get information to here. And you can actually see, Wait a minute. I got an error message, but it's running. Whoa, wait a minute. Hold on a second. Let me All right, so what happened is, this is what our issue was before we got that error. This error right here, it says Mandrill is unreachable, which is, it does a health check. So it goes and makes sure it can ping Mandrill first, and that was failing. And it was failing because, like I said, I brought everything over on a new OS on this Linux Omarchi, and just didn't have everything set up right. So, and actually there's a longer story to that, but I'm not going to go into that. So what we did is we connected it to the MCP because we were doing it through a bridge that we created, but we just connected it to the MCP. But we had to clear this health check, and we thought we did that and it didn't do it. So, because it's hard coded somewhere. But if I bring up, and I should have brought this up. Well, we're actually not seeing anything streaming in there, but we are seeing it over here, which is all that matters. And I've definitely got to make this bigger for y'all. How's that? That's better, isn't it? So we can see just kind of the run as it goes. And you know, it's thinking, I guess. So it knows it's instance 1. And we're just here, all we're doing is having it do checks. We're going to make sure that it can save to Mandrill. We did a Mandrill ping, results were good. We should be able to go here. I think we told them to save a context. Maybe not. Uh-oh. Bear with me, y'all. So we've had 4 bash commands, 2 read commands. You can see over here 1 project switch. That's a problem. Can't read all that, can I? Probably if I made it smaller, I could. Nope. I'm gonna say that's probably project switch. Well, we should see it right here. That was Mandrill ping. Yeah, so Mandrill ping. Anyway, this is kind of how we're gonna watch this happen tonight, as long as these tests all work. I am concerned why that's not running, but I think I know. Let's see, I can close that. It went ahead and fixed it anyway. That thing didn't listen at all, did it? It's like, screw you, man. I'm gonna fix this. I know what it is. Are we gonna save a command? Save a context? That is the question. It's feeling like it's kind of stuck here. And it's my guess is because Claude interrupted it. So let's go start it over again. Be interesting to see how this clears itself or if it does. All right, he stopped it. Let's run and make sure it stopped. I've got to go close ridge control. I got to redo the whole thing, man. That was weird. All right. Got to do everything in the right order. Got to do everything in the right order. All right, we're going to take this back to 4 to 1. So now we can go here and start ridge control again, and we should be able to start wrong place. Start circ. So if anybody's watching live, first tell me where you're watching from. And then is anybody hyped about what everybody, was it Spud? I think that's what everybody's saying it's called, Spud. I think it's supposed to come out tomorrow. That's what I'm hearing. Yes, here. And then we can start it, and we still got the failing. But is it running? So let's go check our dashboard. Take it just a minute here, we'll see. And see, last time we saw it come up here before. Yeah, I'm not feeling good about this. I think that last process is still running in the background. I believe that's what's happening. So here's what we're going to do. We're going to get a clean start. Actually, let me bring that back up and let me see if I can. Now let's get out of here. We're going to restart everything. So that is disconnecting. We just need to stop the spindles. Now what we need to do is make sure there's nothing else, not another process running. So I'm just telling them, check and make sure there's no other processes running out there. Oh, I got to rebuild Forge. I should have known that. That's disappointing, Brian. That is so disappointing. But you did not know that. Or you didn't catch it. You knew that. You knew that. You just didn't do it. Now that's going to take a minute. Kind of see what we got over here. If there's anything I need to save. Yeah, let's have them just ensure. I gotta give them the project name, because if they get to switching different projects on Mandrel's side, we can have issues sometimes. I've been trying to chase that one where I can assign. It should be easy, you would think, but where I can assign each Claude session to their own project control in Mandrel. But I think I had it working for a little bit, but I don't know what happened. All right, this is in Project Forge. We can clear that one. Start anew. All right, let's go check on our build. Did I not? Oh, I didn't build it there. I built it here. Still building. All right, so we did get a context saved here. Oh, no. See, it didn't switch projects. That's disappointing, Claude. Come on, man. Did I not say? I did not say switch. It thought it was still in there. But that's what I was talking about. That's the issue I've been fighting. But we can fix it. We can fix it. We can fix it. Where are you at? Got several forges. There we are. There we are. All right. So now let's go back and check. So that's done. So now we should be able to see there. Let's make sure we're stopped. All right, we're going to start Forge. We're going to move this back to 4. All right, now go back to 2. Why is it dropping out? Yeah, it's, see, we may we may not get to where I want to get to tonight, but we're on a mission though. We're on a mission. You just got to go with me. All right, so we're gonna go here. Forge, bundles, proxy, and our So I think our script is there's something not running correctly, and we're getting errors, but our script is not showing us the errors, so we're hidden. Found it. Okay, let's get this back. Well, that was wild. You want to see that? All right. So we shouldn't be able to start here now. I'm gonna move this to 4, to 1, and there we go. Now it's staying open. That is what we want. So we got Forge up and running and Spindles running. So now we just need to start Ridge Control. And we're gonna start our process again here. Let's Forge test. We're getting closer. I can feel it. I think it's going to work this time. 2026, Brian. Be better if I had a copy and paste there, but I don't have it in this terminal yet. It's a polish item that I haven't gotten to yet. All right, that's 5. And we're running it in Mandrill under Forge test. We're going to say yes. Should be able to start. Let's bring up our activity stream. Let's see. We're getting no errors. Look at that. And it's running. It's running, baby. Now let's make sure it can search. Android context search. Oh, I didn't put the seed document in right. See, it just found it. So it's working. Now we just got to make sure that we can talk to Mandrill. But it's saying it's storing. I don't know why it's using to do right. I think we got an issue. Oh, it worked. There we go. Now we're up and running. The kiln has been lit. The fire has been stoked. That was cheesy as hell, Brian. Cheesy as hell. Stick around for some more cheesy as hell. Thank you. Thank you very much. All right, so now our dashboard, we should be able to see we're running 2 instances out of 5. All of our tools are working. Don't know why this is not working, but that doesn't matter. Zero thinks is a problem. It's probably because I don't have it turned on in Claude. Ah, but we're running this headless. Wonder if we got think on. We got to figure out the think blocks because that's kind of cool. That's something we're missing here. So let's get that going. I think it's a matter of just Alright, so I'm just being very specific here. So I'm telling them check to make sure that we're running Claude Code headless with the think tag on. And I told it to not guess, basically. If it did not know, to go look it up. Yeah, all right, we're good. That's what we want. All right, so we're on instance 4. So we're gonna get this completed here in about, what, probably 6 minutes. So now what we can do is we're going to switch to our actual problem, or our seed that we're going to feed. So let me go here. Let's close this out. Do not need that, and we don't need that. And then we're going to open Typora. Go full screen, and we're going to open our rough idea / problem. And I'm calling this project PDFer. There's probably something already called PDFer, but that's what I wanted to name it. Why is this not rendering right? It's weird. All right, it doesn't matter. All right, so this is what we're gonna work on, and I'll make this bigger. Maybe I forgot. I can't. How do I do that? I gotta zoom in with Control Shift on this. Control Shift. All right, how's that? That's better, right? So PDF to Markdown, and this is the issue that I'm working on right now. It's because we're going to build agents, and agents need Markdown, and we're going to build agents to solve problems, and agents need Markdowns. And then the business world, they love PDFs, right? Like they love PDFs. So we need a good way to get from PDF to Markdown, and we need a good way to get there accurately, right? Not because business needs accuracy. So that's the overall picture. And I think we dive into, so this is a summarization. This is how I work. Because I have a day job that's not regular hours, so I'm not always home. It's not 9 to 5. I have very little time. So my time that I have when I'm driving, because I have a territory that I have to cover, I iterate a lot with Claude app, right? The Claude iPhone app. So this is a summarization of me describing the problem as I know it and how to get to a solution. So I'm showing this live to everybody because I haven't even read this yet. So we're going to go through it, and you can see how crazy my mind works, or how my crazy mind works. So the starting point, my question was, how do we parse PDFs better, right? And I wanted to know why. Like, that's my thing, is why is it difficult to parse PDFs back to text? So the question wasn't how do we parse PDFs, it was what is actually broken and why. And that's always I want to solve a problem. So I need to know why before I can solve a problem. Known symptoms going in: multi-column documents parse as interleaved garbage. Images disappear, tables collapse, text encoding produces gibberish. Every tool has a different failure mode. So because we were going through, PDF Plumber, and I'm not going to be able to rattle off all these, but there was like 4 or 5 of them that that people know about and that are popular, and they all had problems. So we got to the root cause. PDF is a print format, not a reading format, right? So that's when you boil it all down to the basics, that was the basic problem. PDF is descended from PostScript. It's a language designed in the 1980s to tell printers where to put dots. The PDF content stream is a list of paint instructions. So you're trying to take something that's instructions on how to paint on a screen and turn that back into text. So I think, let's see, what are we saying here? Draw, example is draw glyph H at position 72680 and font F1 at size 12. Draw glyph E at position 8680 and font F1 at size 12. So that's how it's encoded. So the file knows where to put ink. It has no concept of what that ink means. PDF encodes visual truth, but has no required semantic layer. Position is mandatory, meaning is optional. So it doesn't care what's there, it's just looking for positions. Well, I don't think doesn't mean it cares what's there, but the point is that's not the primary objective. The spec is fully rules based. It's an ISO standard. So when I got to this part, my brain started switching a little bit. Because, I come from the Navy background. I have electronics background. That's a lifetime ago, but standards, and I used to calibrate test equipment in the Navy. And then in the field I'm in now, you have standards with flooring, right? So you have like IIC ratings and standards with, multifamily buildings. So things like that. So when I saw ISO standards, it just tells me that, okay, there's a set of rules, right? Like there's something that you can work off of. So how do you back engineer that? Or how do you use that to your advantage, right? So it's that rules describe a renderer, not a reader. So still, I'm thinking, okay, we got something concrete here. An optional feature called a structure tree tagged PDF exists that adds semantic meaning, but fewer than 5% of real-world PDFs use it. Oh, okay, I see what it's saying. So this could be an edge case, a structure tree, which I don't even know what that is. So the actual problem inventory. So these are all the problems that we came up with, right? Multi-column reads is one line, and I knew this is really kind of what started me down this path was this multi-column problem. Because what happens, a parser, well, it's going to tell you right here, the parser sweeps left to right, just like we read, right? It starts here, goes left to right. So if you got two columns right here like this, it's going to read, well, it's dropped down, but pretend that did not. It's going to read this whole line together. So it puts these two together. So then you end up with all this nonsense, right? Doesn't make any sense. Broken sentences. And, so that was a problem. Reading order is wrong. PDF stores glyphs in draw order, not in reading order. So how it renders. So you may have something down here that renders before this text up here, right? So that's an issue. You start to understand real quick when you break these problems down why it's so difficult. Tables are broken. No required cell structure in a file. Borders are decoration, not data. So it's just a rendering, right? So this is it's just instructions on how to draw this out. It's not a real table. So what that means is it's just positional, right? So anything inside that, you don't have a cell number or a cell coordinate or like column 0, row 0. Image is lost. So images are just pixel regions. There's no text, no meaning, no attachment to captions. There's nothing like you can have an image in here and there's no semantic meaning to what's around it. It's just an image in this document. There's nothing, there's nothing tying that image to anything else. Font encoding garbage. So then I know this can be an issue. Some PDFs use custom glyph maps with no Unicode translation table, so information may not exist in the file, just meaning that it's going to have this nonsense it's trying to read that doesn't translate to anything that it knows about, right? I think that's solvable, though. I have an idea for that one. Headers, footers, pollute text. So no positional metadata distinguishing body from page, furniture. So everything looks the same in here. Like it's because it's just this rendering instructions. It's just no real order there, right? Scanned PDFs have no text, so when you scan a PDF, and that's actually a big problem too, scanned docs are literally just images, so there's zero text layer. So you're just looking at an image at that point. So what I was trying to solve is if you got PDFs, actual PDFs, not copied ones right now, that's a whole different problem. That's an OCR thing, right? I think I know what I'm talking about there. Maybe not. Somebody else can come in here and say, you don't know what the hell you're talking about, Brian. The key insight, since position is deterministic in every PDF, the problem reduces to, and that's what I was trying to do, that's what I'm always trying to do. How do you get down to the problem and distill it all down to individual things that you can work on? Can you write geometric rules that translate spatial relationships into semantic structure? And I think that was, I did not ask that question that well, but that is kind of the question I was asking, right? So mostly yes, with known failure boundaries. The implicit geometric rules that exist. So you have characters within 3 pixel horizontally, same word. So I'm interpreting, I hope I'm interpreting this correctly, but the way I read this is you're going to have this 3 pixel spacing between lines. So that's kind of a set thing, right? So that's something you can work on. That's what you're looking for. We're looking for rules. We're looking for solid foundations that you can build off of. Lines with 1.5 line height vertically, same paragraph. So 3 pixel horizontally is the same word. Yeah, I said this backwards. I was reading this wrong. Okay, I understand now. It takes me a minute, but I get there. So yeah, so 3 pixel in between the space in between your letters, as long as that's 3 pixel, that's going to constitute a word. So that's a rule. 1.5 line spacing, line height, that's the same paragraph. 2 vertical bands of text across a page, 2 columns. So if we identify this, we know 2 columns. Font size significantly larger than the body, that's going to be a heading candidate. Consistent X indent across lines, that's like a list item. So if you see a consistent indent here, you're going to know that's list items. Grid aligned text blocks, so a table candidate. So if you see text blocks aligned up in a table format, then if it looks like a duck, if it walks like a duck, it might just be a duck. So So we're kind of looking at geometry and shape, right? What can we determine from the geometry of that page and the shape of the page? It says the rule set exists. Nobody has built a complete composable trend. That is just hyping me there. So we move on past that stuff. The proposed architecture core principles separate the layout problem from the extraction problem. Solve layout first, get objects, and then solve extraction per object type. So that was my idea, was why can't we, since I understood the problem and I was relating it to objects. So that's what I had in my mind, right? So if you have a column, that's an object. You have another column, that's an object. If you have an image, that's an object. If you have larger text than the other text, that's an object. So what you're doing is you're looking, since it's a visual, PDFs are a visual image, it's a visual output. You need to convert vision back to text, right? A visual output back to text. So you have to have a translation layer or a way to do that. It's just my thinking. I'm giving it to you raw tonight, man. So I'm thinking, let's convert everything to objects. You can't automate this 100% right now, so don't try to do that. So how can you make it faster and easier? And then also maybe build templates. This is not in here. This is another idea I had as I was doing other stuff today. But as you do this, you can build templates, right? So if you have several PDFs that are following the same format, why can't you build a template? And then boom, you don't have to have human in the loop. But right now, what I'm saying is you convert everything to objects. You present that to the user, the human, in a visual display with objects that you can click on and make annotations and notes. You make your notes. You know what that PDF is. You know how, you can see it. You can see how it's supposed to be laid out. So you know if it's a heading, you know if it's a footnote. So you annotate all of this stuff. You mark it up, annotate it. You package this up, and then you send this to an LLM at that point. And this is the first step. I'm thinking that you can probably get to where you can use heuristics. I'm not saying that word right. And some logic, and probably do a lot of it without. That's the ultimate goal, right? Like, my ultimate goal here is not to just run an LLM on all this. It's how do you build, the logic, because LLMs allow me to get to that logic to solve problems. So anyway, I'm kind of just rambling tonight and giving you an insight of how my mind works. So here's kind of I think this is what we were talking about. We're doing it in layers, right? So you kind of run this thing through in layers. So tool, we're going to use my MU PDF, render each PDF page as a high-res image. So we want a good, clean image, right? We don't want fuzzy. We want it really good and clean. Also extract raw text stream here. So broken but useful later for coordinated clipping. So we're going to pull out any kind of text that we can get at this point too. Even if it doesn't make a lot of sense. From this point forward, we're going to work on images and coordinates, not the PDF text stream. So stage 1 is layout detection tool. While this is a model, fine tune on Pub Layout Net. It's a very small model from what I understand. I think it's very small. And it's tuned on these. It runs locally, no PA. No, right there it is. Model size is 50 to 300. Read down, Brian, read down. 50 to 300 megabytes, depending on accuracy tier. And we got plenty of room. We're not worried about that. And we got plenty of memory. Output labeled bounding boxes per page. So as I was discussing this, there's these tools to do this out there, right? So I'm not coming up with anything novel. I'm just figuring out how to put this stuff together. So object classes, header, these are how we'll kind of define things, right? Header, paragraph, column, table, figure, caption, footnote, list, sidebar, page number, and watermark. And we do not have image in there, but I think image is also already considered an object. We may have to add that. So this will run, right? We get all of this information. This will run. Then the human's going to come in and, we're just imagine this. We're going to use React. So this is the UI. Okay. So here we're going to confirm or relabel anything that's not labeled correctly. We can draw new boxes. We can delete false positives. We can merge things if they need to be merged. We can split. And then we can flag or annotate things for the LLM call. This is just to make sure, right? Like this is just to make sure everything's working correctly. So we come in here and do a quick review. I say quick review. What spawned this whole thing is I think I have like 156 page PDF that I need to render. Convert to Markdown. Stage 3 extraction router. Each confirmed object routes to the right extractor by label. So here is where we get this was the problem, right? Like this was the original problem. You have all of these PDF Plumber, Camelot, Paddle OCR, but not everything was working together, right? Like I couldn't find anything that solved all these problems. Each one of these had an issue. So this is what we're going to do is we're going to run it through these different layers. And then stage 4 is ambiguity handler, surgical LLM. So this is where the LLM can come in and review and use its image reading capabilities, do comparisons, and be able to reason, right? Like this is where that reasoning can really help. I'm sorry about that. I just hit the mic. And stage 5 is reading order assembly, sort objects by page number, Y position, top, bottom, group our columns, get our output ordered list of objects with content and semantic label. And then we start going into Markdown, right? And here's, once we get this done and it's all, so what we're gradually getting this into a more deterministic state, right? We're going from ambiguity. We're going from uncertainty, something that's not clear, and we're going to a more deterministic thing that we can work with. I'm going to try to say that word again later. I can say it fine in my head. So once we get to this Markdown assembly, it's pretty much code, right? Like we can do this. And then here's our assessment, because then the last thing I do, and I do this all the time, and do they tell you always the truth? Probably not, but you do get, it will stop agreeing with everything and give you some, real world advice, I guess, or not advice. That's a bad term. Real world information. So first problem, the multi-column reading order that was broken. We can fix that. Our table's broken, better. It's not perfect, but I think if we can get to better and we can get it to a certain stage, even if the human has to come in the loop, I think that's fixable. Images were lost here, and now we're containing them and actually giving them a name. The font encoding is still an issue because we can't fix that right now this way, but we're going to work on that later. Scan documents broken, better with OCR routing, so here we're going to have some OCR routing in there as well. Heading our hierarchy, before you're just guessing, but here we can, actually mark it because of that human in the loop layer. Headers and footers, same thing. Footnote threading was lost, detected, not threaded. Not sure how much we run into that, but we'll see. So what is one unfixable thing? Custom font encoding. We cannot fix that, right? If the glyph map is missing or corrupt in the PDF plumber reads garbage from that bounding box, that's all you're going to get. Garbage in, garbage out. And if this is our only problem, I'm good with that. We'll ship it, right? We're going to ship it if that's our only problem, and we'll just put a disclaimer. Custom font encoding not fixed. The later I go, the goofier I get, man. So I have no idea, is anybody watching? Anybody at all? If you are, tell me where you're watching from. Tell me a project you're working on. Literally 0 views. Literally. It's okay though. We're creating good content, man. All right, we're gonna go back here. So what we're saying here is the strength is putting that human in in the loop and not trying to just take the human out of the loop right now. But can we speed the process up? See, this will speed, if this works, this will speed the process up for me. So our accuracy targeting, what this is, not V1 scope, not a general purpose parser. Yeah, local pipeline. All right, this is good. So this is the discussion that I had today, the iteration I had today. So now what we're going to do maybe, yeah, we're going to do it. Okay. Well, first of all, let's go check. I think all our runs made. Yep. Instance 5. Do we have contacts saved? Fresh. So yeah, we got contacts from all of our instances here. So we're all good. So now what I'm going to do here in Mandrill, to keep this from in the right project, we're going to switch to, did I create the project here? I did not. I've got to get the LLM to do it because I had a problem with that. That's right. So again, we're going to call this project PDFer because they are some PDFers. And another cheesy joke, man. Another cheesy joke. Thank you very much. I'm here all night. Yeah, we're going to call it PDFer. So we want Claude here to create that project for us in Mandrill. So it's just an MCP tool call to the database. It's going to create a project called PDFer. And then we're going to point it to and read. Already created a directory. Why can I never get this to work right? First, you gotta type right. PDFer. Let me try it this way. Oh, I see the issue. I see the issue. Why did I run it in this? I'm in the wrong directory, man. Oh, that blows. It's all right. We're going to get him there. We're going to get him there. It's going to cheat. I'm going to cheat. Gonna cheat. Oh. That is a shame. That is a shame. There we go. All right, so I'm just telling them to read what we just read, that PDF. I mean, that markdown file. And then I told them to come to Mandrill and create this project, PDFer. So what I'm going to do is I set that as the default project in Mandrill. That way it's always going to switch back, and this is going to be the default project. So it just kind of helps keep everything going there. We've got 0 context here, so we're starting fresh. So now what it did is it went also and read that, like I said, it read that markdown, created the project, and now it's waiting on me to tell it how I see this Forge run going. So this is where I think I do things different. So we've got an idea of the problem, right? Like we know not an idea. We have a solid foundation of what the problem is that we're trying to solve. And then we mixed in some ways to solve those problems, right? Like generically, we're going to run it through these layers. So we have a model of an idea. So how do we turn this idea into a real working project or app? So we could sit here and go to plan mode, and I could iterate in plan mode with Claude Code. And that's fine, but it's too eager in my, in my experience. And you're only going to get the most common, and this is the part that's different. This is the part that I learned early on. you're only going to get those first pass, I call it first pass tokens, right? So when you ask it a question, what's the nearest pizza place, right? So it's just, in that case, it's going to go do a search and actually give you an answer. If you ask it a question like, I'm going to draw a blank. I'm going to draw a complete blank on a good example. All right, I'm drawing a blank, but the point here is if you ask it a common question or a question of any kind, honestly, the way they work, the way the tokens are predicted, and the way it travels through, and this is a very butchered explanation, but the way these tokens are generated and pass through these matrices and get down to your final output, generally it's all probability. That's the way I should have said it. It's all probability, right? What's the most common token that fits here? And then that's how you end up getting your answer, is it gives you the most common, the most probable token. And when you're planning things sometimes, or when you're trying to come up with different ways to solve a problem, you don't always want that most common answer. Sometimes you want to go a little deeper, right? Like you want them to think about the actual problem. And another thing that they do, and it's because they really can't think and they can't really reason, they can't hold on to, concepts real well, right? Now I think they will say they can't really hold on to concepts at all. But I don't know. I'm not going to argue that point. All I know is that this method where you bring an instance in, have them read that seed document, whatever the problem that you're working on, think about it. First, that's the first thing I'm gonna tell right here when I start typing, is that the whole purpose here is they have to think through this whole thing, right? So they're gonna think about the problem and they're gonna come up with a way to solve the problem. They're gonna, in this particular case, we're gonna have them design a plan. They're gonna come up with their own plan of how to solve this problem. Then we're going to have another instance come in after that one's done, read that one's plan, poke holes in it if it needs to be, think about it. Is that the best plan? Is that the best way to do this, to solve that problem? Once they think about it, they're going to either correct the other one's plan, or they can redo an entire different plan and go a different direction. So part of this is giving them some autonomy and having them think. And I'll go to my grave until somebody can prove it to me that when you give them autonomy and don't constrict them, but yet constrict them, if that makes any sense, right? Like, so you put them in this box to work in. In this case, it's a database that they can use to communicate and think about previous instances work. So anyway, that's the idea. So I'm going to type out here and I'm actually going to do it in type world because I don't want to hit enter too soon. So we're going to type my prompt out here. And we're going to start off by saying number. Come on, Brian. Okay, UI is important here and how it flows with the workflow. The presentation of changes is a terrible way to say that. And all right, the number one thing we need to accomplish with this run is to have them think and to see the whole problem, and then they think about how to solve the problem. They design their plan to solve it and save to Mandrill. Then the next instance, we'll read that plan, think about the problem, and decide, is that the best way? Are we missing something? But we have our problems identified, so that is our constraint. Other than that, so the goal here is to be able to parse PDFs as cleanly as we can with a visual interaction using human in the loop is what I said. Should say. Sometimes my brain doesn't process everything. Using human in the loop. UI is important here and how it's presented in the workflow. User needs to be able to see entire process per stage and know status and output of each notable stage. User. I'm gonna say here, think power by. Probably shouldn't do that. I'm not. See, I don't want to. If you give them the problem with doing this, and it's the problem with if you do it, and it's actually a more prevalent problem when you do it only one time and not this looping. Is if you lead them, right? Like if you lead them in a direction, they're gonna latch onto that and they're gonna go that way, even though that might not be the right way, right? So I try to do this as generically as I can. So I think I'm good with that because I've already primed. This Claude already knows what's going on. So he understands the seed document, what it's supposed to be about. Oh, wait a minute. Nope, there is one thing I forgot I gotta add. Yep. This is a very important step. So this is a lot going on here, but it's important, I think. And here we're going to say, oh, it's going to know. I'm not going to say, again, I'm not going to pollute the context. I just know that this is what I need to happen, right? Like, so I'm just trying to give it what I know I want to happen. So they're going to use the project that we created, and they're going to save their reasoning throughout this so they can compound and see the why, right? So I want the second instance to come in and be able to read instance one's reasoning of why it did what it did. And that's where you get to that second instance going beyond those first pass tokens, I think. Because now it's thinking about a problem that it's already given its most common reason, right? Or its most common answer. Because it's the same, even though they're non-deterministic, I get that. But they still gave the most probable answer, right? So now you've got a second instance coming in and saying, okay, wait a minute, is that the right? And then we think about it in a different way. And when you think about it in a different way, it's going to take a different path. And you're going to get different set of tokens. So that's the whole idea here. All right, so now we're ready. We're going to go here. back here. Why is it not working? There we go. There we go. All right. So this is getting to the meat of it. This is where we're gonna decide what goes in that seed document, which is very important because you're building everything off of that. That's your foundation. Let's go read that. Should be able to go here. Let's read that seed document. So let's open. Oh, should be here. Oh, wrong one. Wrong one. Close. All right, let's try this again. Seeds, it's this one. All right, so we're gonna read this real quick. Mission: design a complete buildable architecture for a PDF to markdown pipeline with a human in the loop. Visual UI. This is thinking run, no code. Your job is to reason deeply about the problem, design the best possible solution, and hand off your thinking to the next instance. PDF is a print format. All right, so that's all good. The document identifies the root causes, the problem with feed. You know what we need to give them? I don't think we need to do it now, but we need to give them a PDF to work with. So it's telling it to think. It's you know, emphasizing that, I guess you'd say. All right, that looks good to me. Let's go back over here. And then now what I need to do, first I need to do is close these. We're gonna close that. Nope. Close that one, let's close that one. Go back full screen. doing that. Let's see if we can reset. All right. All right, so now what we need to do is we're going to call this I'm actually going to give it half this time, which I didn't do last time. So it's PDF or design 6.15.md. Is that right? 415.md. We're good. We're going to run 5. Here we got to change this to PDFer. PDFer. Self-assign, yes. Start. Should be able to start this. And now what happens if we go to 4 and we watch? All right. Time didn't reset, but that's okay. So as you can see, what we're going to watch here, it switched to Mandrill right here. Went to contact get recent. Saw there was nothing in there. It knows it's the first instance. What do we got now? Now we got some thinking blocks here. Excellent. I have now read both documents thoroughly. It knows it's I1. It knows what the issue is. Checking on the gaps, the problems that we identified. And now it's working on the actual plan. So it's thinking about the plan now. We should get a... Well, we already got some. So it's planning here now. It's talking about the 5 gaps. So the ingestion stage needs to classify the PDF type and branch strategy accordingly. For born digital PDFs, the raw text stream is much more reliable than OCR. We should prefer it when available and clean. Gap 2, multi-page objects, tables spawning pages, paragraphs breaking across pages, figures with captions on next page. The bounding box per page model doesn't handle this. Need a cross-page linking mechanism. The human review UI will need to support this. All right, let me think about this. Tables spanning pages, paragraphs breaking across pages. Yeah, figures with captions on next page. Okay. Let's see what we're saying. So we need to be able to say this from this page links to this page. Sidebar containing a table, figure group with subfigures, list inside a column. Flat bounding boxes don't capture containment, need parent-child relate. Yeah, now we're talking. Now we're drilling down. All right, step 4. Heading hierarchy. Font size alone is insufficient for heading levels. Need cross-page consistency analysis, identifying all heading font sizes. And across. Okay, so we're doing a little cross-check. What are all the sizes? then assign levels based on relative size ordering. All right, it's a pretty good understanding, right? Data flow contracts. Original pipeline had 7 stages, 0 to 6. Analysis shows stage 4 and there's that word again, ambiguity. I can't do it. I can say it in my head. Ambiguity. Oh, that's a little bit better. All right, it's just another extractor. Fold into stage 3. Must happen before extraction so humans can review it. I agree with that. We numbered to stage 4, so we're going to have 4 stages, 5 really. Each stage has 1 clear responsibility. I agree with that. And that's a much better place that it belongs after all the automation and before the LLM. All right, so we're off, and let's see where we're at here. So we're on instance 2. So instance 1 is done. So I should have more. There's the handoff. So you can see what a handoff is. Says it tells who it is. It tells what it did. Talks about the key decisions it made. Talks about simplifying that pipeline, getting it down to 4 stages. So it's basically trying to take the LLM completely out right here. Well, no, it's got it in here in the extraction if we need it. It designed an API, identified 5 hardest unresolved problems. This is one thing they love to do. They're good at passing the buck, man. No, that's not really what they're doing. They're doing what they're told. Well, I'm least confident about challenge these. SQLite under rapid edit load could cause lag during active review. The 4-stage simplification. Flat parent ID for nesting. All right, so we've got now I2's planning in here so we can see what it's doing. It read all of instant 1's work. Ran the handoff. It knows, I keep hitting that mic. It knows the 5 gaps. Modular monolith architecture. Knows the API was designed and knows the 5 hardest unresolved problems. What I plan to do, challenge the architecture, stress test each decision, design a detailed data model. And this is where you get into, this is where this loop proves out, right? Like you don't get this stuff normally just by talking to it. Design the detailed data model, deep dive the undo system, resolve the cross-page project object problem. All right. And then think about state transitions. So that's what it's working on. And If we go back over here, we can kind of see where we're at. Looks like it just saved. Yeah. Another planning. Challenge 1, SQLite, agree. So it says it's okay. It thinks SQLite is okay. Challenge 2, modular monolith, agree, add task runner. Correct for B1, but I1 missed the stage execution model. Stages 01, 3, and 4 are CPU, GPU bound and must run as background tasks, not block the API server. Need an in-process task runner. Asyncio based, not Celery. WebSockets for progress is correct. Challenge 3, pipeline, 7 to 5 stages. It agrees, refine reading order model. Challenge 4, Canova, Conva.js. Am I saying that right? Conva? Yeah, I don't know what I'm doing. All right, so it agrees with that. We're going to use that. Object labels, refine to 12. What's it taking out? Drop sidebar, just a paragraph for extraction. Drop page number, subcase of page, clarify list equals whole block, not per item. All right. Challenge 6, character level raw text, disagree replaced with span level. So we got our first disagreement. It's a good thing. We like that. 100,000 rows per 50 pages is wasteful. PDF Plumber re-extracts at query time anyway, replaced with span level storage, contiguous same font, text runs 2,000 to 5,000 spans for 50 pages versus 100K characters. Primary purpose shifts to font metadata index for heading hierarchy analysis, not raw text storage. All right. Yeah. As you can see, kind of what I'm showing here is the thinking, right? Like you get challenges and you don't just get those first pass tokens. You get something a little deeper. Or at least, maybe that's too woo-woo to say. Maybe you say it this way, that you get different pass tokens. You get different tokens. You get a different way of thinking about the problem. So it just stored another context, I think. Oh, we didn't get this one, did we? All right, so we're going to output PDF type, page count, page rows, image path, thumb, path, the dimensions, and then our DPI. And our text spans rows. Stage 1 requires page images and page dimension data. Does not read text spans. Stage 1 is our detection to review. Output is objects into rows, label, bound box, confidence, reading, order, source, detected, status unreviewed. Cross-link suggestions are not persisted, computed on the fly at query time from current object positions. Heuristics is cheap, must reflect current edits. All right, stage 2 to 3, review extraction, output modified objects in place. So we confirm, reject. So this is where we review, human review. So from stage 3 to stage 4, we're going to output extractions, rows, one per object or chain with content typed, and then the extractor. Failed extraction, still create a row, empty content plus error. Okay. Cross page chains, pre-pass groups, linked objects, dispatches as unit to extractor. Not sure what that means. I was following everything to that one. Pre-pass groups, linked objects. So that's up here. What was identified as linked objects. Dispatches as unit to extractor. I guess we're saying we're going to pass that to the extractor. Requires one extraction per confirmed non-chain object, one per chain. That's okay. All right, well, this is, where are we at? It's 11:01 my time. I've got to get up and work in the morning, but I really would like to get through this and get an analysis before we close it off for the night. So we're on instance 3. We'll hang in here. Probably got another 15 minutes. Be my guess. Be my guess. Anybody watching live, anybody at all, if y'all are, say hi. Tell me where you're watching from. Nobody on YouTube. Man, YouTube is disappointing me. Nobody on X. It's all right. It's all right. We're getting good content, man. Getting good content. We're gonna show it. Show it in videos. Let's pop back over here to Mandrill and let's see what we got. Let's go here. All right, so this instance is it's working on the UI, screen map, document workspace layout, and canvas interaction model. So it's working on our UI. Got to work on this presentation. I can get more out of this. We're not parsing correctly. Batch workflow, 50 pages, 750 objects. How to not drown. I1 identified this as a hard problem. Number 4. Let me trace the complete workflow for a realistic document. All right, so a decision was made here. Batch workflow design, 50 pages, 750 objects. That's what they're estimating it would be. Finish review resolution. So what they're working on there is the problem of taking a PDF and breaking it into objects. It's going to create a huge amount of objects. So they were saying if you take 50 pages, that's going to translate to 750 objects. And that's way too much time for a human to go through each one is what they're trying to solve now. So they're trying to figure out how to deterministically more parse it before it gets to the human, or the rules for auto accepting something. Yes, user can go back from stage 3 to stage 2 to fix the review mistakes. That is, again, another. I might have been there on that first pass if you did it, but I doubt it. So you get more detail, right? You get more edge cases caught. So it's creating here is another interesting thing because it's all pattern, you know, identify problems, kind of self-critique itself. It's actually this one. So it's identified some challenges, right? Self-challenge, edge cases, and stress testing. So these are questions it's presenting to the next instance to think about. What do we got here on this one? So that was another thing is we want to, you know, try to gather as much data. I'm trying to do this now. We're trying to, because I'm thinking about, you know, fine tuning your local models, making them better. So we're always trying to save data. User corrections are investments, not chores. Make this visible so review feels worthwhile. That's interesting. Psychological design. So they're putting a counter in, makes corrections feel cumulative. So if you've got, you know, I'm 142 of 500 towards a better model. That's interesting. That's really interesting. All right, so where are we at? We're on run 4. So I wish that timer would have reset. I would have had a better idea, but I think it was around 60. We're about 30 minutes into this run, and that's 4 runs. So we got about another 15 minutes, I'm gonna say. So 11:30, we should be done. Let's see what I4 is gonna think about here. What I plan to challenge, this is why I love doing this stuff. So if we would have went with, you know, that first pass, this was its idea. So what this instance is saying is, wait a minute, let's look at that. That's a little too coarse, needs refinement, right? So it's saying here that our plan has Camelot for tables, but Camelot has severe limitations on borderless tables. So that's a problem. The I3's text spans granularity decision says spans correct for UI, correct character level on demand for heading analysis. I need to validate whether on-demand character extraction is feasible for heading hierarchy without persisting it. All right, so it's got some good problems going there. Each cell in the matrix is actually an ordered fallback chain. So basically what we're doing here, or what it's doing here, is it's really trying to find deterministic ways before we send to an LLM. We're getting into more complexity, that is for sure.
My sweetheart, I'll sing every night by her door. I don't mind if there's gray clouds above me. I will find peace of mind, knowing you are there to love me. We'll meet again in the moonlight. I know you'll be waiting there for me.
All right, I4 still planning mode, man. So we're still going.
I'm mad after you. I'm mad about you. I get a kick out of you. Oh, 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 after you.
Interesting design we got here. We're actually building in. I mean, I talked about this, but they're actually building it in to fine tune using this data as we go. We'll see. We'll see. We may be getting out of scope a little bit. That's okay, because we're not going to just go with this either. We got another step. So almost done with I4 here. It's going to address the challenge questions. All right, y'all. We're on the last instance. This is going to be it for the night. We're going to review this plan tomorrow and continue it and hopefully start building tomorrow night. So until then, everybody, have a good night. And this is